Hey everybody, welcome to the first lesson in our third unit. This unit is called sinusoidals, one of my favorite nerd words. So what we're going to look at in this unit is a different type of graph that we haven't played around with before. In fact, what this graph is going to look like is it's going to do something like this. All sorts of cool applications in nature of graphs that look like that. In fact, the sound of my voice right now makes that wave. So what we're going to do to start off this unit is we're going to let the graphing calculator get the equation for us. And then from there, we'll learn how to make these equations and how they work and everything from there. Now, the first thing I really need you to know right now on your graphing calculator, what I really need you to do, this is the most important, you are going to switch yourself into radian mode right now. So I want everyone to stop, hit pause on the video, and put yourself in radian mode. Do that now. Okay, so you're into radian mode. For this unit, we will always be in radian mode. Degrees, essentially at this point, are dead to you. Maybe I'll make a second video just describing why that is. But for now, just trust me, we're in radian mode. So you know how to do a regression already. So I've got this long table of values. I need to be really careful again with the regression because of how many data points there are. And I have to get these things into my graphing calculator correctly. So what you're going to do is you're going to do what you already know how to do, is you're going to go and put all that data in your calculator. So go ahead and do that. Hit pause. I've already got it in. And when you're done getting it in, unpause. All right, you've got the data in your calculator. Now what we're going to calculate is a sinusoidal regression. So again, you know how to do a regression. This is a new one though. So what you're looking for on this one is right there, sine regression. Enter. And then remember, you want to store this thing. I'm going to go into yvars, enter, enter, enter. And you get this long decimals for each of these, okay? Remember, what we're never going to do is we're never going to round those, okay? On the question, it might ask us to round, but when I hit y equals, notice that all those values are there, okay? Now, let's go back and start answering some questions. So determine the regression equation using your calculator, round all values to the nearest tenth. Okay, so what are we going to have here? We're going to have 13.1 sine 0.52x minus 2.1 plus 9.8. Okay, let's go write that down. So our equation will be, says to the nearest tenth, 13.1 sine 0.5x minus 2.1 plus 9.8. Now, right there, I do not get 100% on my diploma. I have to, you have to write y equals for full marks. Got it? Now, from here, we're going to start letting our calculator do the work for us. So we never use the rounded equation that we just put down. We always use this one here that's in our graphing calculator. So first thing we need to do so we can start graphing is changing our window settings. Well, x is time, so the smallest amount of time is 0. It's the course of a year, so x max, probably 12. I'm going to go a little bit bigger, let's say 13. Enter. Scale, I don't know, bigger the better, 10. Now, y is the average temperature of each of these months over the course of the year. So in my table, I see, I think the lowest value is -3 or something. I'm going to go a little below that. Maybe I'm going to go to -7. and the maximum temperature I saw was like 23 or something, so maybe I'm going to go to 30. Scale 1,000, that doesn't even make sense. Again, bigger the better. So I just don't get really thick, dark axes. Look at that nice smooth curve there. That's a sinusoidal graph. Beautiful. Now that we've got that in, we can answer the questions. So the first question says, determine the max and mins of the graph using your calculator. Notice we're not using the table of values. So to find the maximum, go to max. And again, on the Casio, it's a little different. If you're using the Casio, you're probably already done. Okay, max for this one, I get 22.8. We'll round to the nearest tenth. And then minimum. Okay, again, Casio people, you know, you just go Shift G solve and minimum, and you're already done. You're waiting for all us TI people to finish up, right? Left bound, right bound, enter guess. I don't know why they put guess in there. What a waste. Guess. Okay, we get a minimum of negative 3.3. All right. So max, 22.8. Celsius. Minimum, negative 3.3 Celsius. Okay, there was two minimums there if you look at the graph, but guess what? They're both going to be the same because the sinusoidal graph is known as periodic. It repeats. Okay, determine the value of the median line. Now, the median line, think of when you're driving, the median is what's right in the middle of the road. Okay, well, how would I find the middle of the road? Another word for median that I also know is average. This is also the average line. Okay, so how do I find the average line? Well, the average, well, you've been finding the average of two things since you were a little guy, right? Well, for us, I'm going to take our highest value plus our lowest value, and if I want the average of two things, I'm going to add them together. So I'm going to go 22.8 plus negative 3.3 divided by 2. Okay, put that in your calculator. Let's find out what we get. 22.8 minus 3.3 divided by 2. I get an average value, or my median line, of 9.75. Okay, interesting. I'm just going to write down this equation again here at the beginning because it disappeared when I shared my screen. Okay, what does the median value represent? What does the median value represent? Well, the median line, or the average line, represents the average temp over the year. That's what that represents. Now, do you notice right here, 9.75, if I had written that as 9.8, do you see that back in the equation? Right there. There we go. There's our first connection. Okay, very good. Then number 4 says determine the amplitude. Okay, amplitude is, think of an amp in a car. It's boosting the sound. So what the amplitude is telling me, it's how much up and down I go from the median line. So how much up and down from median? Well, how are we going to find out how much we go up and down from the median? Okay, well, if I know my max is 22.8, and I know my median is 9.8, I'm going to subtract those things. That's going to tell me how much up and down I go. Well, that's 13, approximately 13, right? Because we've rounded these values, we've truncated them. Or what I could have done is instead of going max minus median, I could have gone min minus median. And guess what? That's going to give me the same value. Well, do you see right here, 13? What do you see up here? 13. Oh, okay. So again, we're starting to make some connections here. I like it. That's the important part. Okay, let's keep moving on. What does the y-intercept represent in the context of this question? Well, the y-intercept, well, that's when time is 0. Or the initial time. So it's going to be the temperature at time 0, or the initial temperature when we started recording. Okay, what is the period of the graph? Well, period is the time it takes for something to repeat. Well, just logically thinking about it, the period should be just 12 months, shouldn't it? Okay, the period is 12 months. However, we're using a line of best fit. So what we're going to use here is a formula. On your formula sheet is this, 2 pi over b. Well, what's b? So I go back up to the equation that I had, and when we look at the equation of this thing, our b value was 0.5. So I put that in my calculator, and I end up with approximately 12.6. So I know the period should be 12 months. It's talking about the course of the year, but the actual correct answer we're going to use is 12.6 because we always use our regression equation. Now, number 7 and number 8. You should be starring questions like 7 and 8. Okay? Because these are the really good thinking questions that we're definitely going to get. During 1 year, how long is the average temperature? So how long? So I want to know time is equal to when the temperature is above 15. So that means I'm going to let y equal 15 degrees. And you should be good at this from polynomials, right? So you go back to your graphing calculator and you're going to let y2 equal 15. Okay, so let's go do that. Let's go put y2 equals 15 in our graphing calculator. Right there. Or went to y3, whatever. No hair, don't care. Graph. There it is. Well, how long? Well, that's where the region where we're above, right? We're talking right here. So we need to find this intersection and this intersection. We got to find those x values. And guess what? We're going to subtract them. You've played this game before, right? So intersect, first curve, second curve, guess, who cares? Okay, so the first intersection's at 4.7. Do it again. Okay, again, Casio people, you're already done. You're like, come on, hurry up, TI people. Guess who cares? Second one's at 9 point, we'll round to the nearest 10th, 9.2. Okay, so how long are we above? Well, what are we going to do with those two values? We're going to subtract them. So we found that T2 was at 9.2, T1 was at 4.7, and so now time above, we're going to subtract these things. And again, I'm rounding, but it's going to be about 4.5 months. And you're used to that question by now, I'm hoping. Now, number 8 is the really good one. It's a thinking question. So number 8, If the average temperature in the town increases by 2 degrees, what's that going to do to our graph? Well, what that's going to do, if you think about it, is it's going to, here's our graph right now, right? Here's our graph right now. It's doing roughly more or less something like this, right? It's not perfect. But what it's going to do is if we increase this thing by 2 degrees, it's going to take this whole graph. There's our median line. It's going to take this whole graph and it's going to move this whole graph up, right? So what it's going to do is, how would this affect our graph? It's going to move it vertically. Up 2. So what's going to change then? Well, what's going to change is that our median line, our average temp, I'm dyslexic there for a second, our average temp rises by 2 degrees. Now, in class the other day, when we did our unit opener for this, we know that's going to change the d-value. The d-value increases by 2 degrees. Okay, nothing else is going to change. The amplitude won't change. Amplitude is how much we vary from the midline. That's not going to change. Okay, that's a good question. We've had something like that on the diploma where we have to describe it. So as you're going through these questions, again, the things I want you to think about, maybe here what I'll do is just give you, okay, so what I really want you to think about as you're doing this, so this is our equation, just in case you missed the day we did the unit opener. This is our equation. This is my amplitude, how much I vary up and down from the median. This is my median, also known as my average. Okay. The b-value isn't my period, it helps find the period. And again, that equation is on my formula sheet, like that. And the c-value we talked about a little bit on the unit opener, not to worry about it too much. This moves my graph left or right. The answer, we'll talk about that later, isn't a big deal for us in 30-2. When you're doing these again, when you're analyzing these things, you always start at median line first, then amplitude, then period, and then our final question is, has the graph been moved left or right? The answer is yes or no. I never need you to find that value other than doing a regression. Okay, I hope that was okay for you after doing the unit opener the first day. I will see you next time. Adios, amigos.